Yeah, yeah.
Okay, so we already created a virtual machine, and there are like it's 30 GB is allocated for this virtual machine and 1.5 GB RAM and one processor. Now, if I want to add additional hard disk, I can do it. So what you have to do is, like, on the right side, you'll have some commands. Click on add. I want to add a hard disk, so click on hard disk. Next, create a new virtual disk. Specify the size you want to create it. So I want to go for 8 GB, and it should be under test. File options, allocate all disk space now. Disk mode, independent persistent, and policies, optimize for performance. Click on next, click on finish. This will add an 8 GB disk into the server.
First, ఎక్కడ యాడ్ చేయాలి ఫస్ట్?
Right side లో add అన్నది ఉంది చూడండి.
యాడ్.
Commands కింద add.
ఓకే.
Okay. Till now we saw the data files, storing the data files, readlog files, and control files, as well as arclog files on the local file system. That means on the server, the disks which are stamped with operating system file system. Correct or not? So I have a disk called as slash database, and this slash database mount point. What is the file system type of this slash database mount point? What was the file system type? Is it NDFS? Is it FAT?
DBF.
DBO na?
DBF.
No. అది ఎక్స్టెన్షన్ కదా. ext3 file system అండి ఇది.
Yeah, yeah.
So these are nothing but Unix file systems. So we store the files in the local file system type. But Oracle also provides us a different type of file system, which is called as ASM, which stands for Automatic Storage Management. So we can create files on this disk also. We can create a disk, and we can configure it with the ASM, and we can store the files related to the database on ASM file system. And by default, the file system or the disk which is stamped with ASM can only store binary files. That means it can store data files, SP file, readlog file, control file, and data files. But you cannot create a text file like init-test.ora. Init-test.ora is nothing but an ASCII file. You cannot create a text file. It can only store binary files. On ASM, you can only store binary files. But we'll see why Oracle has introduced ASM file system. Why can't we just use ext3 file system? So there are several disadvantages with ext3 file system. So one of them is, right now my slash database, the size of this slash database is allocated 4 GB. Okay, I don't have enough space. The 4 GB has been utilized by all the data files. Now I want to add some more data files. So what I have to do, I have to add another disk into the slash database and have to make it as 6 GB. Okay, that also you can do it. Now, but this is a separate disk and this 4 GB is a separate disk. Physically they are separate. Even though they are logically grouped under slash database, physically they are separate disks. Okay.
Okay.
Now there is a table of around 1 GB on this disk, which is of 4 GB. Now I'm adding another column into this table. When this disk is 4 GB filled, I'm adding one more column. As a result, if I want to add one more column, it cannot allocate the space on this disk. it has to allocate the space from the next available disk. Correct or not?
Yeah.
As a result, one column will be on one disk and rest of all the columns will be on this disk. This will impact the performance.
Okay.
Because it has to search extra blocks. Because it has to make a pointer to the second disk and it has to search on the second disk to get the information. So it will impact the performance. So that is the reason why Oracle introduced the ASM file system. It is independent of operating system. So you can unplug the disk from one of the server and you can plug it into another server. సో ఒక డేటాబేస్ ఒక ASM లో ఉంటే ఆ ASM తీసుకెళ్ళి ఇంకో దాంట్లో వేసేసి అక్కడ ఆ సర్వర్ లో కూడా రన్ చేయొచ్చు డేటాబేస్ ని. It's independent of operating system. That is one of the advantage. And whenever we're gonna add a disk to the existing, like the way we have mount points, we will have disk groups in ASM. Okay? Mount point slash database ఎలా ఉందో ఇక్కడ disk groups ఉంటాయి. ఆ disk group names you can name it as data or redo. Depending upon the requirement, you can name the disk group names. You can have it on any name. So for example, I created a disk group called as data, and initially I created a disk with 4 GB. Now this 4 GB is filled. I have to add another additional hard disk. So I will add another additional hard disk which is of 4 GB into data disk group. As a result, I have 8 GB now. But the moment I add the 4 GB disk, what it will do is like it will redistribute the data. The 4 GB of data which is present on the disk 1, it will redistribute among disk 1 and disk 2. The 4 GB of data will be split 2 GB in this disk 1 and 2 GB in this disk 2. As a result, this disk will have sufficient space as well as the second disk will also have sufficient space.
Okay.
And all the columns of the table will be present in only one disk. So the performance will improve. So one is ASM is kind of file system. It's not a perfect file system because it cannot store all type of file. It's a kind of file system which is developed by Oracle, and it has several advantages like whenever we're going to add a disk, all the data in the disk group or will be redistributed among all the disks which are present in the disk group. The next thing is whenever you are writing information, for example right now I have 2 disks under data disk group. Okay,
Okay.
whenever I'm inserting a table or I'm inserting a data into the table, what it actually does is it will stripe the data across the disks. It will stripe the data across the disks. As a result, if you are inserting 2 GB of data, for example you're inserting 2 GB of data, what it will does is like 1 GB of data it will write into first disk, 1 GB of data it will write into the second disk. Now instead of one input output controller working on 2 GB, there will be 2 input output controllers working on 2 GB. As a result, if it is taking 30 minutes of time, it will reduce it to 15 minutes because 2 workers are working on the request. So another advantage is data striping the data across the disks which are present in the disk group. So that is the reason why if you have multiple disks in the existing disk group, that is better. It will improve the performance as it will stripe the data across the disk. So whenever you are creating disk groups, make sure you have at least 2 disks such that it can stripe the data.
Okay.
Next advantage is mirroring. This is optional. If you want high availability, you can enable mirroring with ASM file system. Mirroring is nothing but if you are writing 2 GB of information into this disk group, it will mirror the 2 GB in the second disk group. As a result, if one of the disk is damaged, the second disk can be used to retrieve the data. So it can also withstand disk failures.
Okay.
But how this mirroring will happen? It is intelligent enough to perform the mirroring because you already know it will perform the striping, right? So 2 GB will not be right now I have, say for example, right now I have 2 disks in this disk group. Okay.
Okay.
Or say for example I have 3 disks in this disk group. I have 3 disks. each of 4 GB. So when I'm writing 2 GB of information, it will be striped into 3 disks. That means 700 MB of information will be written into each of the disk. Okay. Now, whatever the 700 MB of information is written into disk 1, it will store the same information in disk 2. And whatever the 700 MB information stored in disk 2, it will store the same information in disk 1, such that if disk 1 is failed, it can retrieve the data using disk 2. So it will do striping as well as mirroring. సో ఇప్పుడు 2 GB ఆఫ్ ఇన్ఫర్మేషన్ మీరు రాస్తుంటే ఒకటే డిస్క్లో 2 GB ఉండి అదే డిస్క్ని మిర్రర్ చేయదు. ఇట్ విల్ మిర్రర్ అకార్డింగ్ టు ద డేటా ఇట్ ఈస్ రిటన్ ఇన్ టు ద డిస్క్. So it has mirroring, it has striping, and it has rebalancing. Rebalancing is nothing but whenever we add a disk, it will redistribute the data among all the disks in the disk group. Okay?
ఆ 2 GB అనేది ఎనీ టైం ప్రతి డిస్క్ అవైలబిలిటీ ఉంటుంది కదా, అంతే కదా మిర్రరింగ్ ఎనేబుల్ చేస్తే.
అర్థం కాలేదు.
ఇప్పుడు మనం 2 GB 700 MB 700 డిస్ట్రిబ్యూట్ చేస్తాం కదా.
అవును.
మిర్రరింగ్ ఎనేబుల్ చేస్తే ఆ టోటల్ 2 GB ఎనీ డిస్క్ లో అవైలబిలిటీ ఉంటుంది, అంతే కదా.
మిర్రరింగ్ కి దానికి ఏం సంబంధం ఉంది?
మరి అంటే ఇప్పుడు 700 కదా మనం పెడుతుంది, అంటే యాక్చువల్లీ ఇనిషియల్ గా 700 పెడుతుంది అంటున్నాం కదా ఫస్ట్ దానిలో.
2 GBని 700 MB దీంట్లో 700 MB దీంట్లో 700 MB దీంట్లో పెడుతుంది. సో టోటల్ 2 GB అయిపోయింది.
ఓకే.
మరి 2 GB ఫ్రీ స్పేస్ ఏంటి?
ఒక డిస్క్ ఫెయిల్ అయింది అనుకోండి. అప్పుడు
ఇన్ కేస్ డిస్క్ ఫెయిల్ అయిపోయింది అనుకోండి, అదే చెప్తున్నాను. ఇక్కడ 700 MB ఇన్ఫర్మేషన్ పెట్టింది కదా డిస్క్ 1 లో, డిస్క్ 2 లో కూడా 700 MB ఇన్ఫర్మేషన్ పెట్టింది, డిస్క్ 3 లో కూడా 700 MB ఇన్ఫర్మేషన్ పెట్టింది. టోటల్ గా 2 GB అనుకోండి. ఇది 700 MB ఇన్ఫర్మేషన్ డిస్క్ 3 లో ఏదైతే పెట్టిందో అదే 700 MB ఇన్ఫర్మేషన్ డిస్క్ 2 లో రాస్తుంది.
ఓకే.
ఈ 700 MB ఇన్ఫర్మేషన్ ఏదైతే డిస్క్ 1 లో పెట్టిందో ఆ ఇన్ఫర్మేషన్ డిస్క్ 1 లో రాసుకుంటుంది, అండ్ ఈ 700 MB ఇన్ఫర్మేషన్ డిస్క్ 3 లో రాస్తుంది ఫర్ ఎగ్జాంపుల్. యాజ్ ఎ రిజల్ట్ ఇప్పుడు ఈ డిస్క్ ఫెయిల్ అయిపోయింది అనుకోండి, ఈ డిస్క్ డేటా దీంట్లో ఉంది కదా. సో యూజింగ్ దిస్ డేటా ఇట్ విల్ recover. So it will provide the availability. Okay, so it has mirroring, it has striping, and it has rebalance. Striping is striping the input data across the disks which are present in the disk group. Mirroring means storing the same information in a different disk such that if one of the disk is failed, we can recover the data using the next available disks in the disk group. Rebalancing is whenever we are adding a disk to the existing disk group, it will redistribute the data among all the disks. So to have this ASM utility, it is not part of RDBMS software. Starting from 11G, this ASM comes with grid infrastructure software. So apart from RDBMS software, you also need to know how to install grid infrastructure software. So if you want to use ASM, you have to use grid infrastructure software. And right now I have RDBMS software under /Oracle, correct or not?
Yeah.
So it is better and it is recommended to install grid infrastructure software in a different mount point other than /Oracle. So I'll be using /grid. I added a 8 GB disk right now, so I'll be creating a /grid mount point using that 8 GB, and I'll be installing the grid infrastructure software under /grid. Okay. And after that, to use the disk or to create disk groups, I need additional disks, right? I have to create disk groups. Disk groups is nothing but a mount point equal to the Linux level. So in the ASM we'll call it as disk groups. At the Unix level we'll call it as a mount point. Now if I want to create a disk group with 2 disks, I need additional 2 disks. So I'll be adding 2 more hard disks of each 2 GB, and these disks I'll be used to create disk group, and these 2 disk groups I'll be used to create data disk group. Okay. And next I'll be creating or I'll be adding additional 2 disks of each 1 GB, and I'll be storing read log files and control files here. Read log files and control files. That too multiplex read log files and control files. First set of read log files I've stored it on Datadescript. The second set of read log and control files I've stored it on this disk group, and I'll name it as redo. So how many disks additional I have to add? 4 disks altogether.
Yeah.
2 of 2 GB and 2 of 1 GB. And archive destination I'll set it to slash backup for now, because it will take some other time. If it will take some more time if I want to add one or 2 more disks of each 2 GB. So better I'll be using slash backup for archive. So first thing is we have to check whether okay, it's completed now. If you see here, I have an 8 GB hard disk, so I'm good. In addition, I have to add 2 more of 2 GB each. Create new virtual machine. Oh, sorry, new hard disk, 2 GB. Allocate all disk space now. Independent persistent. Go down. Policies. Optimize our performance. Next. Finish. And also there are some other advantages, like if you take the ext3 file system, it has to submit input output request to Unix, correct or not? DBWR write the data buffers from buffer cache to data files, but internally it has to submit input output request to Unix such that Unix will perform the actual input output, and whenever it submits the input output request to Unix, it will work in terms of 512 bytes or 1 KB depending upon the operating system block size. But when you have the disk or the data files on ASM, it is independent. Input output request will not be submitted to Unix. Input output request itself will be submitted to ASM. ASM will also have a volume manager. So that volume manager will actually perform the input output request. So it will work in terms of AMU, automatic memory unit, or something. I don't remember it exactly. It will be in terms of 4 KB or 8 KB. So as a result, the input output performance will also improve. It occur difference.
Okay.
And remember, ASM is independent of operating system. That itself is another advantage. Okay, 2 GB is added. I'll add another disk now. Hard, create new virtual disk. 2 GB. Independent persistent. So whenever if someone asks you what is the difference between ASM and local file system, you can go for striping and mirroring. Those are the two advantages what we'll get from ASM. And also it itself acts as a volume manager such that it is an independent of operating system. ఈ 3 advantages చెప్పాలండి. And whenever we have, if you are storing data files or the files related to the database on ASM storage, the database, from the database perspective, you'll have some additional process apart from the regular background process we have. So the additional background process are asm and rbal. These are the additional two background process which a database will have whenever you have an ASM configured for the database. So this ASMB will actually performs a communication between ASM and the database. This is a process responsible for communication, maintaining a communication between database and ASM. Because there should be some communication, then only it can submit the input request to ASM. Okay, and rbal using rbal background process, it actually access the disks. Rbalance process will be used to access the disks, which are part of ASM. And now, as ASM is independent of operating system, even ASM needs to have something in order to perform input-output operations. So what Oracle did was, whenever you configure an ASM, automatically an instance will be started. That instance is called as an ASM instance. So all the input-output operations will be performed through ASM instance. What is an instance?
Combination of memory structure, like
Ashish?
combination of memory and background process.
No. Okay, SGA plus background process.
Yeah, SGA, sorry.
Memory and supplement. We should make it as SGA. And SGA plus background process is nothing but an instance. So even ASM instance will have SGA, and even it will have background process. It will have DBWR, it will have PMON, it will have SMON, it will have RBAL, and it will have ASMB. So this will be the background process of ASM. And SGA, it will be smaller in size. It probably around 300 to 400 MB. It's a lightweight instance actually. It will not consume lot of memory. Usually it will be 300 to 400 MB. Or in the real time it may be around 1 GB or 2 GB. That's it. If the database SGA is bigger, like if the database SGA is 512 gig or 200 gig or 128 gig, in that case it may be 1 GB or 2 GB. So it's a lightweight instance. Using ASM instance, it actually performs the input-output operations. And remember, in order to communicate, in order to perform a communication between ASM and DB, we should have a listener up and running. Listener is required to have a communication between ASM and DB. And whenever you have ASM configured, the listener should be running from this home, not from DB home. So now you'll have two homes, right? One is grid infrastructure home. We're installing grid infrastructure software. So the location where we install the grid infrastructure software, it is nothing but it's a grid infrastructure home. And here we'll have RDBMS home. Now, as I have two homes, I can start the listener. Even grid infrastructure home will have LSNR CTL utility. Even RDBMS home will also have LSNR CTL utility. But you need to make sure listener should be running from ASM home. So listener should be running in grid infrastructure home, not from RDBMS home, whenever you have ASM configured. And remember, 90% of the companies are going for ASM now. No one is using local file system. So you should configure the listener on grid infrastructure home. Now, and there are some additional processes like CSS, which stands for Cluster Synchronization Service. This is a process which actually synchronizes the communication between RDBMS or the database and the ASM instance. Synchronization in the self, whenever you start the database, the ASM needs to know, okay, the database is running and this database will be using ASM. So that will be taken care by cluster synchronization service. It will actually synchronizes our database and ASM. Let us go ahead and add additional 2 disks of each 1 GB. Stuck up.
Okay.
Okay, so we can download it from Oracle site directly. So what you have to do is like go to Downloads tab, click on Oracle database.
Mm-hmm.
So which one is our operating system? Ours is Linux 32-bit, right?
Yeah.
So which one I have to select? Linux x86 or Linux x86 64?
x86.
Yeah, x86 is 32-bit. So I have to go for this one,
Yeah.
and I have to click on select all. See all. When you click on see all, okay, then wire network connect అవుతున్నా.
Okay.
So now here, when you click on see all, immediately you'll get all the Oracle products related to 11G. Now you have to click on the grid infrastructure software. So this is Oracle grid infrastructure 11G release 2. You need to click on this zip file. So this will start the download. Okay. Now as I already have the grid infrastructure, I'll copy it straight from the Windows machine. Okay, I'll copy the software into slash backup. So I'll delete some of the files. I'll remove Oracle 11G out. And I'll copy it the grid infrastructure. Slash sbin slash config. Okay, it's 127. Okay, this is the folder. I'll copy it to slash back. Okay, this will take some time. So in the meanwhile, we'll do some additional things. So right now we added altogether 5 disks. One is 8 GB. So if you want to look at the disks which you added, you'll not get in the mount points because we haven't stamped anything. We haven't stamped any file system on those disks, correct or not? Those are just raw devices and we haven't mounted anything. So remember, all the hard disks will present under /dev and it will be starting with SD. SD stands for standard disk. Now SD star. Okay. Now you can see some additional disk apart from what we have. Initially we only had SDA. We added 30 GB which is 30 GB hard disk which is SDA, and we created some partitions in that disk, and those partitions we mounted each of them into /database backup Oracle. Now we have some additional disks B, C, D, E, F, and B is 8 GB, CD is 2 GB, EF is 1 GB. Okay. Now I have to format this /dev/SDB first. So the moment you got the pen drive, you have to format it, right? In a similar way, you have to format in Linux also. To format, we'll be using the command fdisk space /dev/SDE and then enter. I want to format SDB, sorry. So I'll be using fdisk/dev/SDB. And this command, I have to invoke it from root user. I cannot do it as Oracle. So in the real time, it will be taken care by system admin.
Okay. No,
okay, here if you want to see the available options with fdisk, you have to type in M. M gives you the M stands for help, and it will show you the available options what you have. Okay, వినిపిస్తుందండి?
Yeah.
Okay, so to add a new partition, we'll be going for N. So right now we have to add a partition to this disk. సో ఒక డిస్క్ ని ఎన్ని పార్టిషన్స్ అయినా చేయొచ్చు మనం. ఇప్పుడు మీ ల్యాప్టాప్ లో తీసుకోండి 500 GB హార్డ్ డిస్క్ ఉంటే మీరు CDEF చేసుకోవచ్చు కదా. అదే విధంగా 8 GB నేను ఒకటే పార్టిషన్. ఐ వాంట్ 1 GB 8 GB ఆఫ్ వన్ పార్టిషన్. సో ఫస్ట్ థింగ్ ఇస్ ఐ హావ్ టు యాడ్ ఎ పార్టిషన్. సో ఐ హావ్ టు గో ఫర్ N. Here I have to specify whether it's a primary partition or extended partition. As this is the first partition I'm creating on the disk, it will be a primary partition. So I have to go for P. And then partition number will be 1. This is the first partition number. Next, disk is internally divided into cylinders. So totally 1044 cylinders equal to 8 GB. So how many cylinders you want to allocate for this partition? I want to create a partition of 8 GB. So I want to go for all the cylinders. So first is, so starting from 1 to 1044, I want to allocate all the cylinders to this partition. So that means I'm creating an 8 GB partition. Now I have to save this into the partition table. So there will be a table called as partition table that will store the information about all the partitions. So in order to save the information into the partition table, we'll be pressing W. W will write whatever the changes which you made into a partition table. Initially when I did ls-ltr/dev star, I only got SDB. Now I'll get SDB1 also because I created a partition. ls-ltr /dev/sdb star. Okay, so if you see here, I have SDB as well as SDB1. SDB1 is a part of SDB. That is the reason why the frame number will be same, 8, and 16, it's the header. This will be 17 because this is the first partition, so it will be the next available number. So this is the partition which we have now. Now we have to stamp this partition with a file system like ext3 file system. So first you have to perform a raw formatting. After that you have to stamp the partition with a file system type. So I have to stamp it with ext3 file system because this partition I'll be storing it, or I'll be using it to store the grid infrastructure software. So you cannot use ASM to store the grid infrastructure software. Those are not binary files. Those are some executable files and those are some text files. So we have to use general purpose file system. General purpose file system is nothing but an ext3 file system. So first I have to stamp it with ext3 file system. To do that, the command is mke2fs space /dev/sdb1. So this will make an ext2 file system, or it will stamp /dev/sdb1 with ext2 or ext3 file system, I guess. 1 second, let me get the command. Okay, it's mke2f minus j. If I have to stamp it with ext3, I have to go for minus j space /dev/sdb1. So this will stamp sdb1 with ext3 file system. Okay. Okay, now it is done. So see the difference now. Now it is a binary file. So earlier also it's a binary file. So there will be no difference. Okay. Now we have stamped SDB1 with ext3 file system. Now we want to mount this disk into /grid, like the way we have /oracle, which is under /dev/sda2. In a similar way, I want /grid under /dev/sdb1. Okay. Adhamotna? Yeah. So now we have to create a folder called as grid under /grid. So I'll be making mkdir/grid, and after that we have to use mount /dev/sdb1/grid. So this will mount /dev/sdb1 to /grid. Now if I do df minus capital T, I will have additional mount point with /grid, and it is 8 GB, and it is ext3 file system. But every time I reboot the server, this disk will not be automatically mounted into /grid. So if I want to do that, there is a file called as fstab, file system table. We need to update the file system table in order to get this mounted each time we reboot the server. So we need to open /etc/fstab file. Here we have to specify /dev/sdb1. The mount point is /grid. File system is ext3. Defaults, go for 0 and 0. These are we need to add it into the fstab. Specify the location which like the disk which we are using, and then the mount point, file system type, and then default 0 0. Now each time we reboot the server, /grid will automatically be mounted. Save and exit. Done. Okay, the copy is done. So I'll install the grid infrastructure software now. So I have to create a grid home. So mkdir -p /grid app product 1120 /grid app product 1120 grid. Yeah, I'll go for this home. Okay, I'll be using this location as a grid home. Now I have to change the ownership also. -R Oracle :o install /grid. Okay, done. I'll go into grid folder. chmod -R777 star. It will make some of the files as executable files. Now /run installer. So in the real time, first we'll install the green infrastructure software, then we'll install the RDBMS software.
So,
Because we'll be creating the database on ASM file system. So we need to have the ASM in order to create the database on this. So here, the first option will be this for a cluster. We'll see it in the last end of the classes, real application clusters. So we have to go for a standalone server. So install and configure green infrastructure for a standalone server. Check on this option and click on next. Or you can also only install the green infrastructure software. If you install only green infrastructure software, only utilities will be present, but ASM will not be configured. If you want to configure the ASM also, you have to select this option.
okay.
Click on next. If you want to install this option, if you want to select this option, then you have to invoke ASMCA. ASMCA stands for ASM Configuration Assistant.
Okay.
And this will be present in grid infrastructure software home. Using this ASMCA utility, you can configure the ASM. So I'll go for this option, install grid infrastructure software only. Click on next. This option తీసుకుంటాను. Next. I'm going for install and configuration both. Okay, here I have to specify the disk group name which I want to create. I want to go for disk group _ data because I'm storing the data files here. And then redundancy here. You want to enable the mirroring or not. As I said, mirroring is an optional thing. If you don't want to enable the mirroring, you have to select external option. If you want to enable the mirroring, you can select either normal or high. Difference between normal and high is, in normal, you will have only, let me select normal. Okay, before doing that, first thing is, we have to use the disk which we created. ఇప్పుడు STE, we have to use EDCDEF for ASM. But these disks are owned by root user.
Yeah.
And even though if I change the ownership of this disk, each time the server reboots, the ownership will be changed to root again.
Oh.
So in order to avoid this problem, we'll be stamping the disk which we'll be using for ASM with ASM libraries. So there are some ASM libraries you need to install. First, check whether ASM RPMs are installed or not. So to check whether an RPM is installed or not, we'll be using rpm-qa grep oracle ASM. Okay, so these are the RPMs which are required in order to configure the ASM libraries.
Okay.
So we already have it. So first what we have to do is like oracle ASM configure -i and then enter. Here you will be asking, this utility will be asking you who will be owning the disk. So we want the ownership of the disk to be Oracle, correct or not?
Yeah.
So select Oracle and enter. To which group it belongs to. Go for O install or go for DBA and then enter. Next, each time the server reboots, do you want to load the ASM libraries? Yes. If you load the ASM libraries only, then the ownership will be changed to Oracle. Scan ASM on disk boot, yes. Okay, done. After that, you need to start the ASM libraries. So to start the ASM libraries, we'll be using Oracle ASM init. This is to configure. This is to start the Oracle ASM for the first time. Next time, whenever you reboot the server, automatically your Oracle ASM libraries will be started because you selected Y option here.
Okay.
For the first time, you have to go for init. This will start the Oracle ASM. Okay, it's done. Now you have to stamp the disks C, D, E, F with Oracle ASM. To do that, Oracle ASM, create disk, disk1 /dev /sdc. Okay, first, in order to do this, first we have to create the partitions on each and every disk. So we have to go for fdisk /dev /sdc, N for new, P for primary, 1 partition. I want to allocate all the cylinders. So I'll go for 1, 261. W to save the content. In a similar way, I have to repeat the same steps for all the disks. Make sure you do it correctly. If you select the wrong disk, you'll be gone.
Okay.
std n p 1 1 2 6 1 w. E and P 1. If I don't give anything, it will take the default values. Default is 130. W. Okay. The last one is F. Okay, now if I do ls minus ltr /dev/sd star, still, okay, I'll do one thing. ls minus ltr /dev /sd star 1 pipe grep minus v sd a. Okay, so if you see here, I have C1, D1, E1 and F1. Still they are owning by root, correct? Root and disk. That means actually whenever you stamp the disk with Oracle ASM libraries, there will be another folder created under /dev Oracle ASM disks. Here you will have some additional disks here. One second. Okay, I haven't created the disk yet. Okay, I have to stamp it with Oracle ASM. To do that, Oracle ASM, create disk, disk1 /dev /sdc1. Next disk. Oh, let me delete the disk. I want to make it as disk1, disk2, disk3.
Okay.
Oracle ASM, delete disk. Okay. If you don't understand it, just stop. Stop me. I'll repeat it again.
Yeah.
Disk 2, std1, disk 3, okay, now ఇదేంటి అర్థమైందండి నేను చేస్తుంది grep minus v అంటే నెగెట్ చేస్తుంది అనమాట. It will not search for SDA. It will search for rest of the disk. So I'll get only B1, C1, D1, E1. So these are owning by root, and look at the frame numbers 833, 849, 865, 881. Now ls minus ltr /dev Oracle ASM /disks. See here, you have disk 1, 2, 3, 4, and this will be the same frame number 833. So it actually creates a symbolic link, disk 1 as a disk 1, and it will be pointed to C1, this will be pointed to D1, this will be pointed to E1, and this will be pointed to F1, and these are owned by Oracle. So we'll be using the disks which are present in this location. This indirectly points to these disks.
Okay.
So whenever we configure the disk with Oracle ASM, it will be stored under dev Oracle ASM disks. And you have to compare them using these frame numbers. B1 is used for grid infrastructure home, so forget about this. The rest of the frame numbers will be same. 833, 849, 865, 881. Okay?
Yeah.
Yeah. Now go back again, click next. Maybe it will show. Okay. Discovery path you have to give where the files are, where the disks are present. So Oracle ASM / disks. In this location I have the disks. Click on OK. Now I'll have all the disks here.
Okay.
Now if I select normal and if I select only one disk group, see what will happen. It will error out saying insufficient number of disks selected. So if you want to enable the mirroring, we have to select at least 2 disks and click on next. Now I'm able to do that. So that means at least 2 failure groups are required if you want to go for normal redundancy. Each of the disk itself will act as a failure group. Disk 1 will act as a failure group for disk 2. Disk 2 will act as a failure group for disk 1. Correct or not?
Yeah.
Yeah. So for normal, we require 2 failure groups. For high, click on next. It will say insufficient disks. Select 3 disks. Click on next. It's good. So for high redundancy, we have to go for 3 failure groups. That is the difference between high and normal. For high, we'll have additional failure groups. For normal, we'll have just 2 failure groups.
Okay.
Now I'll go for external. I don't want to enable the mirroring. And then I'll just click on these 2 disks. So each of 2 GB. So total, I'll have dg underscore data with 4 GB of space. Click on next. In a similar way, you'll specify the sys password for Oracle database. You'll also need to specify the sys password for Oracle ASM. It's Oracle, 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 Oracle. Or else you can actually select the use same password. Just click on S, click on next, click on S. Yeah, change the path here. /grid app product 1120 grid. And base, we can use the same base which we use for Oracle RDBMS software. The base is Oracle app Oracle, correct or not?
Yeah.
So I'll go ahead and click on next. Yeah. Okay. Swap space and physical memory, you can ignore them. But there are 2 parameters which are not set properly. So these are fixable parameters. I'll click on fix and check again. This will give me the script and I'll execute the script. This will change the kernel parameters. Okay, done. Click on OK. It will check again. Okay. Memory and swap, you can ignore it because I have 1.4 GB. Expected value is 1.5. That doesn't matter. Swap space, that's okay. It is not able to check it out. So just click on ignore all. Click on next. Click on finish. This will install the grid infrastructure software as well as it will configure ASM. Now, if you want to go into the disk groups and if you want to view the files, first you have to invoke asm_cmd utility, because you cannot directly go to cd/. There are no mount points for asm disk groups. You cannot do /dg_data because dg_data is not present under slash.
Yeah.
So you have to invoke an asm_cmd. It is an asm command prompt. So once you issue asm_cmd command, you'll go to asm_cmd prompt. Here you can do cd plus dg_data. Like the way you have slash in Unix, you have plus here.
Okay.
So plus is the root directory. And then you can, once again you'll have asm_cmd prompt. Here you can do ls. It will list all the files which are burned in this disk group. And if you want to copy any files from ASM to local file system, you can copy it. cp space. For example, if you want to copy sp file test.ora, and you can specify the location where you want to copy it to. Oracle app Oracle product 1120 db1/dbs. In this way, you can copy the files from ASM to local file system. You can also copy the files from local file system to ASM using cp. You can specify the path, source path, which is local file system, sp file test.ora space dot. This will copy the file to the current directory. Or else you can specify plus dg_data. And if you want to delete any files, rm-rf. If you want to delete a directory, rm-rf. For example, you want to delete the data files, just rm-rf data files. And asm_cmd, if you want to make a directory, mkdir. That's it. These are the things you have to know. And if you want to know about the mount points, like you will do df-h in Unix. In a similar way, if you want to know what are the disk groups available and what is the total space allocated, what is the free space present, the equivalent command here will be lsdg. This command will show you the total space allocated and used and available space. And you have to invoke asm_cmd utility by setting Oracle home to grid home. Oracle home should point to grid infrastructure home here.
Okay.
Oracle SID should point to ASM. So the ASM instance name will be plus ASM. These are the ASM instance name should be plus ASM. So you have to set Oracle SID to plus ASM, Oracle home to grid home, and path should include grid home/bin. After that, you need to invoke asm_cmd. Okay.
Okay.
And as I already told you, we'll have some additional background process, ASMB and RBAL. ASMB for communication between ASM and RDBMS database, and RBAL to access the disks which are present in the ASM. And there are some parameters associated with the ASM instance. As ASM is an instance, it will also have an SP file or a P file. So there are some parameters in this SP file. One is ASM_power_limit. This is one of the parameter. The other one is ASM_disk_string. This parameter will specify in which location ASM needs to search to get the ASM disks. So when I was creating the disk group, I changed the discovery path to /dev oracle asm/disks, right? So
Yeah.
it is searching the disk for at that location. That is nothing but ASM_disk string. Here we have to specify in which location ASM has to look for the disk which it has to use. Then ASM_power limit is nothing but, as I said, whenever we are adding a new disk to the disk group, it will perform a rebalance. That means it will redistribute the data among all the disks, including the new additional disk. Correct or not?
Yeah.
So with at what speed it has to perform the rebalance. So this value will take 1 to 11. 1 means lower, 11 means higher. So if you go for power limit 1, it will take a lot of time to redistribute the data. If you go for 11, it will take less time to redistribute the data. But if you increase the parameter from 1 to 11, it will impact the database performance badly. So whenever there is high load on the database, you need to make sure the power limit is set to the lower value. Whenever there is less load on the database, you can make it to 11. At any moment of time, you can change the rebalance power.
Okay.
So if you want to add a disk group to the existing, if you want to add a disk to the existing disk group, first you have to connect to the ASM instance. So first you have to set all these parameters. After that, we'll be doing SQL plus /sysdba, correct or not? To connect to the database in a similar way, to connect to the ASM instance, we'll do SQL plus /sysdba. But here, sysdba is not the privileged user. Sysasm is the privileged user.
Okay.
Then, to add a disk to the existing disk group, we'll be using the command alter disk group. Disk group name is dg underscore data, add disk, and we'll specify the location, flash drive, Oracle ASM, disks slash, probably I have HDH1. So this will add the disk to dg underscore data, and it will perform the rebalance using this power limit, and the default value of ASM power limit will be 1.
Okay.
Now if you want to change the power limit, you don't need to change the power limit parameter. What you can do is like alter disk group name dg underscore data, rebalance power. If you want to go for 11, you can just say 11. And then after that, if you see the load running on the database, you can decrease the rebalance power using alter disk group dg underscore data, rebalance power 1. And if you want to stop the rebalance for some time, even 1 is causing database performance degradation, then you can stop the rebalance. To stop the rebalance, alter disk group dg underscore data, rebalance power 0. By setting rebalance power 0, it will stop the rebalance. And remember, you will have the space available after completing the rebalance. The moment you add the disk to the disk group, it will not show you the free space. It has to perform the rebalance, then only it will show you the free space.
Okay.
And if you want to check the progress of rebalance, there is a view called as $asm underscore operation. This will give you how much of rebalance is done, how much of work left, and how much will be the time, estimated time.
Okay.
Okay, the installation is almost done. We have to execute this root script. This will actually bring up the cluster synchronization service. This is very important. This script will actually perform everything. This will configure the ASM. This will bring up the CSS, cluster synchronization service too. So enter, just press enter. Yeah, these files are already existing as part of RDBMS installation. So you should not override the files. Just go for N. If you specify Y, that's it. Your RDBMS software will not be running. Okay. So it will add ASM instance to the Aura tab. After that, it will bring the cluster synchronization service.
Okay.
Okay. In 11g, it's Oracle High Availability Service. The first thing is it will bring up Oracle High Availability Service. I'll tell you what is this Oracle High Availability Service. Till now, each time you are rebooting the server, you have to start up the database manually, correct or not?
Yeah.
Whenever we have this High Availability Service, automatically the database will be coming up. I'll show that in a moment of time. So first will be High Availability Service. After that, it will start the cluster synchronization service.
Okay.
Okay, it's done. ps minus ef pipe grab pmon. Okay, it's not yet done. So click on OK. Now it will start the ASM. Okay. Yes, minus F, grep, Pima. It will take some time. It will also create the listener. As I told you, listener is required to communicate between ASM and database. Okay, now I have the ASM. So as I said, the ASM instance name will be plus ASM. Okay, it's saying that something is failed. Just click on OK. Automatic storage management configuration assistant failed. Just click on the details. It will give you what caused the issue. Starting automatic configuration assistant failed. That's okay. Just click on close. Click on close again. Okay. Now ps -ef pipe grep pmon. Okay, I don't have ASM. So it was unable to start ASMCA. So it only installed the green infrastructure software. So as I told you, to configure the ASM, we have to invoke ASMCA. So /etc/oratab. As it hasn't configured the ASM instance yet, it hasn't added the entry. So export Oracle home, grade, product, 11 to 0, grade, path equal to $path, $oracle underscore home, /bin. Now invoke ASMCA. Okay. I have to reconfigure the ASM. So I have to specify the password. So Oracle, 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 Oracle. Okay. Specify the disk group. I'll be creating DG underscore data. External. I'll select these two disks. Click on OK. So if you see a disk group for server parameter file, that means as ASM is an instance, it will also have SP file, and SP file will be stored in DG underscore data. And ASM parameters, as I told you, it will have ASM underscore power limit and ASM underscore disk string. This will give the location where it has to search. And in 11G, this parameter is deprecated. You don't need to specify it. In 10G, you have to specify that. And ASM underscore disk groups will show you what are the disk groups present under ASM. And the default power limit value is 1. So only you will have just these three parameters. Click on close. Click on create ASM. Password entered, that's okay. Click on yes. Probably it has failed because I need to update /etc/oratab file. First, it will create a listener. So it was unable to start up the listener because of etc/oratab. Sorry, /etc/hosts. This is pointing to 127. Okay, it should be good. We'll see now. Okay, it's able to successfully create the ASM. Click on OK. Okay, now I have one disk group. If you want to create additional disk groups, you can create it by selecting the create button here. You can specify the disk group name and you can select the disks.
Okay.
If you don't want to do it through graphical user interface, you can also do it from ASM instance. So that I'll show you, because this is very simple. Create, specify dg underscore redo as a disk group name and select these two disks and specify the external.
Okay.
It's easier, but I'm not doing it. Click on cancel, click on exit. Yes. Okay, as I set all these three parameters, first we'll go into command prompt. asm11g ls dg. So right now I only have one disk group. Let me maximize the screen. I only have one disk group and the disk group name is dg underscore data. The total size allocated is 4 GB. Free is almost around 4 GB.
Okay.
Total MB 3 GB. And this is a disk group name. And what type of disk group I created? External redundancy. So it will also show you the type. Now exit from, we'll use exit to exit from asm11g. And if you want to connect to the ASM instance, we can go for SQL/SysDBA or we can go for ASM. But if you want to have a super user privilege, you have to use this ASM.
Okay.
Now select star from $asm underscore operation. First I'll show you $asm underscore operation. No rows written because there is no rebalancing going on now, because we haven't added any disk to the disk group. Next, select, or let me describe first, $asm underscore disk. This will show you the disks which are available for the ASM. Select, name, OS underscore MB, total underscore MB, free underscore MB, from $asm underscore disk. So these two are part of the disk group. So that is the reason why it is showing the names disk 1 and disk 2. And the OS MB is 2 GB. The total MB is also 2 GB. Free MB is almost around 2 GB. As these disks are not part of ASM yet, the names will not be shown. Okay. Now select. Okay. There is another view called as $asm underscore disk group. Just there are 5 views in ASM which you need to know. One is ASM operation, ASM disk group. I'll show the other two.
Okay.
Select group underscore number, name, total underscore MB, free underscore MB, from $asm underscore disk group. This will give the information at disk group level. So I have one disk group, dg underscore data, total and free MB. Either you can go to asm11g or you can use these views to get the information.
Okay.
Now select name, path, header underscore status, total underscore MB, free underscore MB, from $asm underscore disk. Okay, so the header status in asm underscore disk, there is a column called as header status. This will tell you whether the disk is part of the disk group or not. If the header status is member, that means it is part of the disk group. If the header status is provisioned or candidate, these are not part of any disk groups. You can be use these disks to create a new disk group or to add it to the existing disk group.
Okay.
Whenever the header status is provision, candidate, and the third one is former. Whenever the header status is of these three values, it can be used to create a new disk group or it can be used to add to the existing disk group. Now we'll create a new disk group using these disks. So create disk group data underscore dg, sorry, redo external redundancy external, and then I have to specify the disks here. One is orcl colon disk 3, disk 2, and the other one is orcl colon disk 3. So these are we can, oh yeah, ఒక పని చేస్తాను, ఫస్ట్ డిస్క్ 3 ఒకటి allocate చేస్తాను, తర్వాత I'll show you how to add to the existing disk group.
Okay.
ఒక్క నిమిషం command. Make it as dg underscore redo external redundancy disk orcl colon disk 3. So this will create a new disk group with external redundancy. If you want to go for normal, you can specify normal here. Okay, now name path see here, now this became a member, disk 3. Next, this header status is still provision because we haven't added this disk. So to add a disk to the existing disk group, we'll be using alter disk group. Disk group name is redo underscore dat. Sorry, dg underscore redo add disk orcl colon disk 4. These are will add the disk to the existing disk group. Okay. But see here, within the disk group, all the disks should be of the same size.
Okay.
Because of the rebalancing thing. If the disks are not of the same size, it will create some problems. So within the disk group, you need to make sure all the disks are of the same size. Across the disk groups, you can have different disk sizes. If you take here, one of the disk group has 2 GB of disk, the other disk group has 1 GB each. So across it doesn't matter, but within the disk group, all the disks should be of the same size.
Okay.
So that is the reason I'm adding this to dg underscore redo. Actually, even now it will give you, okay, see here, now it is showing rebalancing. The power is 1, but it actually have completed now because there was not much of data to redistribute. It was an empty disk.
Okay.
Yeah, so if it was, it has to do some work, it would have given the estimated work, estimated time, and the remaining time.
Okay.
It will also show you the power, and if you want to change it, change the power, alter disk group dg underscore redo rebalance power. and you can specify the number which you want.
Okay.
Now, how to drop a disk from the disk group? Alter disk group, dg underscore redo, drop disk. I can just specify here disk 4. I'm dropping, I'll drop disk 3. Instead I'll drop disk 3. So while dropping the disk, we have to specify the disk name. While adding, we have to specify the path. That is the difference. Now if you check the header status, it will be former. We saw provision and member, right? Now this time the header status will be former for disk 3. The reason for that is it was earlier part of the disk group, but it is dropped now. So that is the reason why the status is former. So even former can be used to add it to the existing disk group, or it can be used to create a new disk group.
Okay.
If you want to drop the disk group itself, the command will be drop disk group dg underscore redo. This will drop the disk group. Okay.
Group name ఎక్కడ కనిపిస్తుంది? dg underscore redo ఎక్కడ కనిపిస్తుంది? కనిపిస్తుందా?
అది vdol asm underscore disk group వెళ్తే కనిపిస్తుంది.
Okay.
Okay, let me create the disk. Okay.
Yeah.
If you are adding multiple disks at the same time, you have to go for comma.
Okay.
Now you'll have dg underscore data and dg underscore redo.
Yeah.
Now if you want to know what are the databases which are using the ASM, there is a view called as ASM underscore client. $, ASM underscore client.
Okay.
Right now no database are using the ASM, so it will return nothing. And the other thing is, can you guess what will be the status of ASM instance? Will it be no mount, will it be mounted, or will it be open?
It will be mount status.
ఇన్స్టెన్స్ ఎప్పుడు ఏ స్టేట్ లో ఉంటుందండి? ఇన్స్టెన్స్ స్టార్ట్ అయింది అంటే నో మౌంట్ లో ఉంటుందా, మౌంట్ లో ఉంటుందా?
No mount.
సో ద స్టేటస్ విల్ బి స్టార్టెడ్.
Okay.
Select status from $instance. Always ASM will be in started mode. There is no mount.
Okay.
And if you want to check the background process associated with the ASM, you have to go for ASM underscore. For Oracle background process, it is Ora underscore. For ASM, it is ASM underscore. So you will have the regular background process like PMON, VKGen, DAG, PSP, LGWR, CKPT, SMON, MON, MMNL. Next, apart from that, you will have ASMB as well as RBAL. RBAL is there.
Okay.
And ASMB will be associated with the database. So you'll find that in the database background process.
Okay.
And check the listener whether we have the listener or not. PS minus CF grep LSNR. Okay, the listener is running from grid home.
Okay.
And there are some set of new commands now. CRS underscore stat hyphen T. This will show you the cluster resources. The moment you install the grid infrastructure, there will be some cluster resources which will be created. And ASM is part of that cluster resource. So you can check the status of the ASM. So ASM is online. And also you can check the status of the disk groups. Data disk group dg underscore data is online. dg underscore read is online. and also you can check the listener. And if you want to shut down the ASM instance, you should not go to SQL plus /SSDVA or sysasm, and you should not issue set immediate. Once you have the grid infrastructure, you cannot issue startup and shutdown by connecting to the SQL plus. Everything should be done using the cluster utilities. So in order to stop the ASM, we'll go for srvctl stop ASM. This will stop the ASM. But before bringing down the ASM, you need to make sure you have to stop the disk groups. So first we have to stop the disk groups. To stop the disk group, srvctl stop disk group. srvctl stands for server control and crvctl stands for cluster control. Disk group dg underscore data. Sorry, disk group -c dg underscore data. This will stop the disk group. Now if I do crs underscore stat -t, dg underscore data is offline.
Okay.
And it will also show you on which host it is running. So it is running on the test host. The server name is test.
Okay.
srvctl stop disk group -c dg underscore redo. Okay, done. srvctl stop ASM. These are we have to bring down each and every resource. Okay, done. crs underscore stat -t. And now in order to bring down the listener, we should not use lsnrctl utility. We have to go for srvctl stop listener -l listener name. Listener name is listener here.
Okay.
Okay, the next are the two extra services. One is CSSD and Dismon. If you want to stop this, the command will be crsctl stop resource ora dot cssd. These are actually cluster resources, so you have to go for crsctl. crs underscore stat -t. Okay, I have to stop the Dismon also. crsctl stop resource ora dot discmon. Okay, now if I do crs underscore stat -t, everything will be down. And this cluster, ఈ cluster ki parent ఉంటుంది. That is nothing but HAS. HAS stands for High Availability Services. If you want to check whether HAS is up and running or not, we'll be using the command crsctl check HAS. So it says High Availability Service online. Actually, this High Availability Service will bring up all these services. So whenever you reboot the server, first High Availability Service will be started automatically. And after that, it will start each and every resource automatically. You don't need to bring it up manually. And if you want to bring up all the resources at once, all the resources are offline now. If you want to bring it all at once, crs underscore start -all. This will bring up everything.
Okay.
In a similar way, if you want to stop it, first let us check the status. If you want to stop everything, -all, this will stop everything. Either you can go one by one or you can use this command. Even after stopping all the resources, the crs underscore stat -t will work because it will communicate with HAS to get the status of these resources.
Okay.
Now, ఇంకొక 2 minutes 5 minutes అండి.
Yeah.
ఇంకా చాలా ఉంది ఏఎస్ఎంలో. ఇంకా డేటాబేస్ క్రియేట్ చేసి ఏఎస్ఎం ఎలా చూస్తారో చూపివ్వాలి. అండ్ 10Gలో ఇంకా చాలా డిఫరెన్స్ ఉంటుంది. 10Gకి 11Gకి చాలా డిఫరెన్స్. ఇక్కడ నుంచి ఈ గ్రిడ్ ఇన్ఫ్రాస్ట్రక్చర్ నుంచి చాలా డిఫరెన్స్ వచ్చేసింది 10Gకి 11Gకి. సో దాంట్లో అది కూడా చూపివ్వాలి మీకు 10Gలో.
బట్ ఇదంతా థియరిటికల్ గా చదవాలి కదండి, అంతా అంతే కదా.
యా,
స్టెప్స్ అన్ని గుర్తుండాలి బాగా.
యా. అండ్
అంతా ఇది వాడతారు కదా ఆల్మోస్ట్.
యా, అండ్ ఇది మీకు వచ్చింది అనుకోండి ఒకసారి, యూ విల్ బి ఫెమిలియర్ విత్ ద ర్యాక్ ఆల్సో. అంటే ర్యాక్ లో కూడా సేమ్ కమాండ్స్ వాడతాం. ఓకే, నౌ
అది ఒక మెయిన్ టాపిక్.
యా, యా. CRS-CTL stop HAs. You can go for CRS_stop -all, which will stop all the resources in the cluster. If you go for CRS-CTL stop HAs, first it will stop all the resources in the cluster, as well as it will bring down the HAs. As a result, as it is bringing down the HAs also, if I do CRS_stat -t, it will not be able to communicate with HAs. As a result, it says it cannot communicate with the CRS. It's nothing but HAs. Okay?
Okay.
Yeah, okay, and I'll end up the class and I'll continue on Tuesday.
Okay.
Yeah. Okay then, bye.
Yeah, thanks. Yeah.